Group 7, the halogens. Group 7 consists of the four elements fluorine, chlorine, bromine and iodine, and the radioactive element astatine. Of these five elements, chlorine, bromine and iodine are generally available for use in school. These elements are colored in dark and going down the group, Table 9.4. They exist as diatomic molecules, for example Cl2, Br2 and I2. They show a gradual change from a gas, Cl2, through a liquid, Br2, to a solid, I2, Figure 9.12, as the density increases. They form molecular compounds with other non-metallic elements, for example HCl. They react with hydrogen to produce the hydrogen halides, which dissolve in water to form acidic solutions. They react with metals to produce ionic metal halides, for example chlorine and iron produce iron, 3, chloride. Displacement reactions. If chlorine is bubbled into a solution of potassium iodide, the less reactive halogen, iodine, is displaced by the more reactive halogen, chlorine. As you can see from figure 9.13, the observed order of reactivity of the halogens, confirmed by similar displacement reactions, is decreasing reactivity from chlorine to bromine to iodine. You will notice that, in contrast to the elements of groups 1 and 2, the order of reactivity decreases on going down the group. Table 9.5 shows the electronic structure for chlorine and bromine. In each case the outer energy level contains 7 electrons. When these elements react they gain 1 electron per atom to gain the stable electron configuration of a noble gas. You will learn more about the stable nature of these gases in the next section. For example, when chlorine reacts it gains a single electron and forms a negative ion, figure 9.14. Table 9.5 Electronic structure of chlorine and bromine. Chlorine is more reactive than bromine because the incoming electron is being more strongly attracted into the outer energy level of the smaller atom. The attractive force on it will be greater than in the case of bromine, since the outer energy level of chlorine is closer to the nucleus. As you go down the group this outermost extra electron is further from the nucleus. It will, therefore, be held less securely, and the resulting reactivity of the elements in group 7 will decrease down the group. The halogens and halogenic compounds are used in a multitude of different ways, figure 9.15. In the reaction of chlorine with potassium iodide, both Cl atoms in Cl2 gain an electron from an iodide ion, one thus forming 2 chloride ions, Cl. The iodine atoms so formed, by the loss of an electron, combine to give an iodine molecule, I2. The iodide ion has been oxidized because it has lost electrons. The oxidation number has increased. Chlorine has been reduced because it has gained electrons. The oxidation number has decreased. Fluorine is used in the form of fluorides in drinking water and toothpaste because it reduces tooth decay by hardening the enamel on teeth. Chlorine is used to make PVC plastic as well as household bleaches. It is also used to kill bacteria and viruses in drinking water. Bromine